So here's your rules for adding and subtracting matrices. Please write them down. Okay, so we have two matrices, or three or four, or whatever. You need to add or subtract them. All you need to worry about is to have the same dimension. We both have to be 2 by 2 or 2 by 3 or whatever. Then we just go and we add corresponding elements. Right? So the first row, first column guy is one matrix. I got the first row, first column guy in the other. We do that for every entry. Just about that. Or so if we have two matrices, like that. First one's a 2 by 2 matrix, second one's a 2 by 2 matrix. We add them. Yeah, so what do we get when we add them? Yeah, so for our first entry, we're adding this guy and this guy. We get 9. We get 9, 10, 11, and 14. And that's basically all we have to do for adding. Same thing with subtracting, other than we just subtract our numbers. Yeah, just add them to the part. This guy gets added to this guy, here, here. Alright, so that's basically adding and subtracting now. Other little guy, multiplication by a scalar, just any number. So when multiplying by a scalar, which is just any real number. You guys probably heard that in physics or something. My first year in university, second semester I took a class of linear algebra. It was all matrices, and I thought that I was large, but it's just any number. So basically, that's just my whole story. That's math 122 at U of R. So basically, we just every entry in the matrix gets multiplied by the number. Kind of just like multiplying with brackets. So if we have a number outside our matrix, 3, and we have a matrix. We have something that looks like that. The number outside, that just means we have to multiply that matrix by the number. Each entry in the matrix can be multiplied by 3. So when we multiply that out, what do we get? Multiply that 3 right in the bracket for the matrix. Multiply these brackets. Questions about that? No? Now this is multiplying 2 matrices together. It's a little different. When we're looking to multiply 2 matrices, big thing we want to look out for is the first point here, multiplication compatible. Otherwise, you can't do it all. So, if the columns in the matrix on the left aren't equal to the rows in the matrix on the right, you can't multiply these at all. It won't work. So, if you're given a question and you have first matrix is an A 2 times 3, you want to multiply that by a 3 by 1 matrix. The thing we want to look for here, 2 middle numbers. those two middle numbers there are the same. So that's with our multiplication. And if they're not, we can't do it at all. And then another thing to look for is these outside numbers, 2 and the 1. That's going to be the dimensions of the matrix. If you don't get a 2 by 1 matrix, do that. You won't get it. And now the way we do this is to take the elements in the first row, multiply all elements in the first column. We do the same thing for each spot. So this part here is going to be first row times second column. And then it keeps going, first row times third column. I know that probably doesn't make a lot of sense, but we have an example. We have two matrices like that. First thing we do is check and see if it's 10 multiplied. Are these multiplications compatible? Yes, we have. The 2 by 2 is the 2 by 2. 2 columns there, 2 rows there. So we can do that. So now when we multiply them, this little part here, this first row, first column part. What I mean by that is we take all the entries in the first row and multiply the entries in the first column. We're going to take the 2, we're going to multiply that by 6. Start off with. This is the first one in this row, this is the first one in this column. Then what we do is we add it. The other 2 multiplied together. Now take 3, second element in the first row, multiply it 4, second element in the first column. Yeah, we're going to end up with a 2 by 2 matrix. So now when we do this entry over here, take this guy here, the second row and first column. Now we take the second row, 5 and the 1, and multiply it to these guys, or the first column, so sorry. Yeah, so we go 5 times 6. Yeah, this is a different entry. Yes, another entry. Then the 1 and the 4. Those are our 2 entries, are going to be our 2 entries in our first row. And we'll do in the second row, take the first row guys, so the 2 and the 3, and we multiply it to the second column guys, 3 and the 2. So it's going to be 2 times 3 plus 3 times 2. And we're going to use the 5 and the 1 over here. And we're going to use this column. So, that's top. The second row and second column. So we can do this column. Questions on how we do those? So So here we take our first column and our first row and multiply them together. Second row, first column. Multiply it over here. So now when we figure these out, what do we get? What's that? 24, just get a 12 here, 12 here, 24. Yeah, we have a 30, a 4. Oh, 6, 12, yeah. 17. And that's our time. No, that's what I want to do. Next, let's go ahead and do another multiplying one.
Yeah.
So here I have two matrices. What's that? Yeah, here we have a 2 by 3. Here we have a 3 by 3. Like these middle numbers here are the same.